convexity of the bond. Convexity. So I have given this note which is going to appear on the screen at the end of the cell practice question number 50. So you come to page number 38 of this chapter and you will be happy to note that note is already typed there, so you will not have to write. But first we need to understand what we are going to discuss. What is the relationship between the yield and bond price? This is inverse relationship, but the relationship is not a straight line, it is convex. Can you see it is convex? In your schools you were taught convex, concave. So this kind of line, if you see this point, origin, it is convex, and if it was something like this, we call it concave. So because of the shape of this curve, they have used the word convexity of the bond. So what is convexity of the bond? It shows the relationship between price and bond, price and yield, inverse relationship, but it is not a straight line, it is a curve. How to calculate the price of the bond when the yield changes? So we have learned a concept called modified duration. We have learnt a concept called modified duration. So what is modified duration? Let us revise modified duration. Just focus on understanding. Modified duration means if yield changes by 1%, price will change by modified duration percentage in opposite direction. Price will change by modified duration percentage in opposite direction. So I have written a line which if you can't read, I'll dictate. Modified duration tells you that if yield changes by 1%, price will change by modified duration percentage in opposite direction. Which means, which line represents modified duration concept? The straight line. Modified duration assumes linear relationship. Modified duration assumes linear relationship. It is based on the concept of duration and it measures the relationship between yield and price when the yield changes by a certain percentage. But there is a big drawback in modified duration. It assumes linear relationship. So for example, right now let us say we are here. This is the yield, this is the price. So at this point both are equal, but let us say the yield changes by 1 or 2%, let us say by 2%. So what will happen? This modified duration will say this will be the price of the bond, whereas actually the bond price will be this. Similarly, suppose the yield increases by 1 or 2%. So this is the value received by, given by the modified duration, but actually the value is more. So this is the true value and this is the value as per modified duration. Here this is the true value, this is the value as per modified duration. So that means modified duration does not give us true value change. It will only help you when the change is very small. When the change is very small, say for example, right now it is 10 from 10.05%, 10.01%, very small change, the gap will not be much. For a very small change like here 1 or 2%, sorry not 1 or 2, 0.1, 0.2, then the gap between these two lines will not be much. But if the yield changes by, as I said, 1 or 2%, then you will see the gap will keep on increasing. As the change in yield is higher and higher, the gap between the price as per modified duration and the true value will be more. So what convexity does, it tries to fill that gap. It will only make some more advancement over the modified duration, and it will tell you how much adjustment should be made, how much adjustment should be made for the modified duration so that we get closer to the true value. That is convexity. So we'll do the calculation of convexity, and then convexity based value will be more closer to the value given by modified duration, because it tries to fill that difference which is because of the nature of the curve. Okay, so that is the logic, and as far as we are concerned, we just have to know what is convexity, what is the importance. I have told you, modified duration assumes linear relationship. It does not give you true value when the YTM changes by a higher percentage, whereas convexity will help us to get a more accurate value of the bond when YTM changes by a higher percentage also. So it fills that gap, that is between modified duration and the actual value. Now we will read your note. Modified duration is a measure of rate of change in bond price on change in YTM, which means if modified duration is 2, a 1% change in YTM will lead to 2% change in the bond value on the opposite side. I have explained this line. Modified duration assumes that the relationship between the YTM and the bond value is linear, means a straight line, and inverse. Relationship is linear and inverse. The graph of the relationship between bond price and YTM will be a downward sloping straight line. This is what modified duration assumes, that the relationship between the YTM and price is a downward sloping straight line. So this is what modified duration assumes, and this is what actual relationship is. Okay, because of that the value given by modified duration will not be true. Next line, the reality is that relationship between a change in bond price and change in YTM is not linear, it is curvilinear, convex, and because it is because the time value of money compounding effect is happening. Convexity is a better technique to find the change in the value of the bond on change in YTM. Convexity is a better technique to find the change in the value of the bond due to change in YTM. The bond value calculated using convexity is closer to the value calculated using the present value method. So there are 3 ways we can calculate the revised bond price. Now don't write, understand. Revised bond price can be calculated in 3 ways. One is PV method, which is the accurate method. But suppose I don't want to apply PV method, the next accurate method will be convexity method. And the least accurate method will be modified duration method. So this is the order. This is less accurate. This is least accurate. And I am going to take some example to check this statement, that convexity based revised bond price will be very close to accurate answer, that is PV method, whereas modified duration based answer will be far away from or away from the present value method. Now we are a student, we are more interested in number crunching. So let us solve. Let us first see the formula of convexity. The formula of convexity is summation x w into 1 plus x upon current bond price. Okay. So using convexity, the percentage change in the price on the bond on change in YTM. First find convexity. There are two steps involved. First find convexity. And that is, the formula is summation xw into 1 plus x upon current bond price. So your question is, what is x here? X means interest. And what is w? W is the present value of cash flow. So what I have to do? I have to take year. I have to take cash flow like we have done in the calculation of bond. Cash flow will be basically coupon plus redemption. Then I will calculate present value, and then I will multiply present value into year. X is year, and again I will multiply 1 plus year. Don't want to write? Don't write, because I am going to solve a question in next 1 minute only. And then you will see how to actually apply, and divide by the current bond price, which is the total of the present value. That will give you convexity. Okay, that will just give you convexity, a number called convexity. Convexity is the second derivative. Second derivative of second order or second derivative. But we are not going to enter into that. Duration is the first order derivative. Convexity is the second order derivative. So it becomes a little more complicated. Now, next task is how to use convexity to calculate the percentage change in the price. First you find convexity, so that will try to fix the gap between the modified duration line and the curve. So you see this formula carefully. It is minus modified duration into yield change in terms of percentage point. Now first I will erase and then I will explain only this portion. If you look at it, this gives you the change in the price of the bond. This gives you percentage change in the price of the bond due to modified duration. So many questions we have solved. Modified duration multiplied by percentage change in yield will give you percentage change in price. But this time I will take modified duration. I will not ignore it. Modified duration is my starting number. But as I said, I have to fill that gap. This is modified duration. Understand? And this is the curve. So I have to fill that gap. So what they are doing? Plus. Because the change you can see is here. Actual figure is this side. So I have to fill that gap. So plus C by 200. Now here the role of convexity is there. Convexity divided by 200 plus yield change in terms of percentage point square plus change in YTM square. Now this is derived formula, it's a second order derivative, so we will not be able to derive in the classroom, but at least logically it improves the answer given by modified duration by filling that gap by making this adjustment. C divided by 200, C is convexity, plus yield change in terms of percentage point square. So then you will ask me to solve a question. There is a question printed below. There is a question which is printed below. So solve that question. We will solve this question in 3 ways. That is, we will try to find out the revised bond price in 3 ways, using modified duration, using convexity and using PV method. And you will see for yourself, convexity based answer is closer to PV method. Question is 10% bond, maturity 5 years, face value 100, YTM also 10%. This is just to keep the calculation easy. I have taken YTM and coupon rate equal, so you can calculate duration fast. Anyway, what is the question? Find the duration, find modified duration and find convexity. Thereafter, suppose YTM changes from 10 to 12. Now it is originally 10, it changes to 12%. Find the value of the bond using modified duration, convexity and PV method. So in this problem I have to calculate convexity also. So we have to add one more column today, x into w into 1 plus x. So write down in your notebook, write down question on convexity, page number 38 of this chapter. First we will draw a 5-column table. Year, which I will write x, then cash flow, then present value of cash flow, which I will write as w. W stands for weight. X into w. X into w will help you to calculate duration, and x into w into 1 plus x into 1 plus x, that will be required for convexity calculation. So we'll solve one by one. Year 1, coupon 10 rupees, 10 divided by 1.10, the present value factor is 10%, so 10 divided by 1.10, 9.09, 1 multiplied by 9.09 is 9.09, and 9.09 multiplied by 1 plus 1, 1 plus x is 1, so 1 plus 1 2, this number multiply by 2, you will get 18.18, 18.18. Then go to year 2, coupon 10 rupees, 10 divided by 1.10, 2 times equal to 8.26 into 2, 16.52. 8.26 into 3, 16.52 into 3, 16.52 into 3, this is xw into 1 plus 2, yani into 3, 49.56. Please come to year 3, coupon 10, 10 divided by 1.10 to the press equal to 3 times, 7.51. Into 3, 22.54, into 4, y4, 3 plus 1, 4. this number into 4, 90.12, 4, 10, divide by 1.10, 4 times equal to 6.83, into 4, 27.32, into 5, 136.30, 5. Now this time you will write 110, 10 rupee coupon, 100 rupees redemption. 110 divided by 1.10, 5 times equal to 68.31, into 5, 341.55, into 6, 2049.30. Now take total of PV of cash flow, that is the total of the weights, and it should come to 100 rupees because discount rate and coupon rate both we have taken as 10%, and redemption is also at par. Then take total of this column. Take total of this column, so this will help you to find duration. Take the total of last column. Total of last column, yes, come on. This will help us to find the convexity. This is price, this is the numerator of duration calculation, and this is the numerator of convexity calculation. So write down below, duration is equal to 417.01 divided by 100 is 4.17. You can find duration with the help of shortcut formula also. PV annuity factor into bracket YTM comma N into 1 plus YTM. But in any case, for calculating the convexity, I need the table. So both ways you can do, by using the shortcut formula for duration or by using the tabular format. In any case, I have to prepare the table, so I had done it. Now write down modified duration first. Modified duration will be duration upon 1 plus YTM. Duration upon 1 plus YTM. 4.17 upon 1.10. So that comes to 3.79. 3.79%. Right, 3.79%. Then write down convexity. Summation x into w into 1 plus x upon current bond value. Go to the last column of the table. Total of the last column of the table, 2343.76 divide by 100 current bond value. So that is 23.4376. 23.4376. Now write down. So this basic calculation we have done. We have got modified duration, we have got convexity. Now we have to find the revised price of the bond when the YTM increases from 10% to 12%. So first we will solve by using convexity. So the formula for calculating percentage change in price of the bond is equal to minus modified duration, minus into modified duration. Why minus? Opposite direction. If yield increases, the price will decrease. So opposite direction is reflected by this minus 1 into yield change in terms of percentage point. So actually this calculation gives me the change in the price of the bond due to change in yield as per modified duration, and then we are doing some adjustment to that, plus C by 200 into yield change in percentage point square. C by 200 into yield change in percentage point square. So I am going to now tell you how to put the numbers. -1 into 3.79 into 2. So this gives you answer in change in price as per modified duration, and then we will now give the effect of convexity. Plus 23.4376 divide by 200 into change in the yield is 2% into 2 square. So that is minus 7.58 plus 0.47, that is minus 7.111%. So it has given the effect of that gap. Just to explain you again, so right now it is 10%. It has increased to 12%. So as per modified duration, this will be the change. Okay, so if the price of the bond is suppose P0 here, it will be P1 and this will be 7.58% change. But then this convexity says no, the change will not be 7.58, it will be this 7.11 rather than 7.58. So price will fall, but the fall will be this much, not this percentage. Got it? Therefore revised bond value will be 100 minus 7.111%. 100 minus 7.111%. So that comes to rupees 92.889. 92.889. Now write down using modified duration. This we have just now seen. As per modified duration, the change will be 7.58%. So using modified duration, revised bond value is equal to 100 minus 3.79 into 2. So the change will be some 7 point some percentage, 7.58%. So the answer is 92.42 rupees. The answer is rupees 92.42. And one more calculation is pending using PV method. This will give you accurate answer. Revised bond value will be equal to 10 rupees coupon. What is 10 coupon into PV annuity factor into bracket 12% comma 5 plus 100 into PV factor 12% comma 5. So that should be equal to now 10 into 3.6048 plus 100 into 0.5674. Check. Is it right? And if you think it is right, then please go ahead and solve. So how much you are getting now? You are getting 92.79. You are getting 92.79. So now if I make a summary, you will see convexity is closer to present value method. So write down summary, method and value. So first method is convexity, which is 92.89. Then modified duration, which is 92.42. And then PV method, which is accurate 92.79. So this is 92.79. Convexity is 10 paise away from this, whereas this modified duration is much away from this. So that is PV method. Now we'll write one more question on convexity. So write down one more question. This I will dictate. Please write down one small question. Consider a bond with a face value of rupees 100. Consider a bond with a face value of rupees 100 and coupon is equal to 10% per annum. And coupon is equal to 10% per annum. The bond has a maturity of 5 years. The bond has a maturity of 5 years. To keep our calculation limited, I have taken same face value, same coupon rate, same maturity, and it is trading at par. So its YTM is also indirectly, they are saying current YTM is 10%. Write down, compute. You can write yourself fast. YTM of the bond, which I have already actually mentioned in the question, will be 10%. Duration and modified duration, already calculated in the previous question, you will get the same answer. New price using PV method. New price using PV method. If market interest rate increases 1%, market interest rate decreases 1%. So this time we have taken 1% instead of 2, and we have taken both plus and minus. New price using PV method, if market interest rate increases 1%, market interest rate decreases 1%. Next question D, show that the relationship between interest rate and the bond price is inverse. Oh, that's a very wonderful question after solving so many questions. And not linear. Relationship is inverse but not linear. So here also it is changing by 1%, here also it is changing by 1%, but the change in the price will not be equal. Change in price will not be equal. That will indicate that the relationship is not linear. Even though it is plus and minus 1%, but your answer in terms of percentage change in price is not equal. Then point number D, compute convexity. Compute convexity. And then compute the new bond price. Compute the new bond price using convexity. Compute the new bond price using convexity. If interest rate increases by 1%, interest rate means market. If market interest rate increases by 1%, if market interest rate decreases by 1%. So same problem we have to solve by PV method, convexity method, and we can also solve by modified duration method also. So this way the question can be asked to you for convexity. So first write down one note. As the bond is trading at par, YTM is equal to coupon rate. YTM is equal to coupon rate is equal to 10%. Is equal to 10%. Second note write down. As the bond is trading at par, comma, YTM is equal to coupon rate is equal to current yield. is equal to current yield. Therefore, duration can be calculated by following formula. Therefore, duration can be calculated by following formula. Right? Already seen shortcut formula. You could have applied this in the previous answer also. Duration is equal to PVAF into bracket YTM comma N into 1 plus YTM. And that is equal to 3.7908 into 1.10. 3.7908 into 1.10, and that is 4.17. You got the same answer in the previous question also. Then write down modified duration. Modified duration equal to duration upon 1 plus YTM. 4.17 upon 1.10. Same answer. 3.79%. 3.79%. Then write down, it means, very easy. We are just repeating this much. Up to this, nothing new. Already same data was used in previous question for understanding purpose. It means 1% change in YTM will change bond price by 3.79%, will change bond price by 3.79% in opposite direction. Will change bond price by 3.79% in opposite direction. So even though they have not asked in the question, but we can just write 2 lines, no harm. New bond price when YTM increases by 1%. New bond price when YTM increases by 1% is equal to, so this is as per modified duration, 100 minus 3.79%. 96.21. New bond price when YTM decreases by 1%. New bond price when YTM decreases by 1%. 100 plus Y plus inverse relationship. 103.79. So, as per modified duration, this you can see the drawback. It is increasing by the same percentage, it is decreasing by the same percentage. But actually it will not happen. Now write below, it will change by a different percentage. New bond price, now we are using PV method. New bond price when YTM increases to 11%. New bond price when YTM increases to 11% by PV method. By PV method. So what I'll do, I'll simply take 11% discount rate now. So write down 10 into PV annuity factor into 11% comma 5 plus 100 into PV factor into bracket 11% comma 5. Ten into 3.6959 plus 100 into 0.5935. Please check the factor. Is equal to 96.31. Is equal to 96.31. So what is the percentage change? 100 minus 96.31. Percentage decrease in price. 100 minus 96.31 divided by 100 is equal to 3.69%. Is equal to 3.69%. Now we'll do the same exercise when YTM decreases to 9%. So next calculation, this box now. New bond price when YTM decreases to 9% by present value method. Under that, 10 into PV annuity factor, bracket 9%, 5 plus 100 into PV factor, bracket 9%, 5. Solve. Check the factor in your calculator. 10 into 3.8897 plus 100 into 0.6499, and the answer comes to 103.89. Therefore, percentage increase in price. Your price was 100 rupees, it has increased to 103.89. So the increase in percentage will be 3.89%. Increase in percentage is 3.89%. Can you see both are different? This feature is called convexity. So the relationship is inverse that we have proved. When it goes up, it goes down. When it goes down, it goes up. And they are not equal. So it is convexity. So write down note, the above calculations prove that there is an inverse relationship between YTM and bond price. And it is non-linear. Because these 2% change are not equal. This we have discussed in the property of the bond also, bond theorem. Now we'll calculate the convexity. But to save time, I will just ask you to write one note. The same table we have drawn in the previous question. So write down the heading convexity. Then write refer previous example. There is no point in right now investing the time. You have to write exactly the same thing. So refer previous example. So what was the convexity in the previous example? It was 23.4376. So write down convexity equal to refer previous example equal to 23.4376. Convexity equal to refer previous example equal to 23.4376. In the exam, don't write refer previous example. The previous question can be on Forex also. Right. So next write down revised price of the bond. When YTM increases from 10% to 11%. So write down the answer. The formula is percentage change in the price of the bond is equal to minus modified duration into yield change in terms of percentage point plus C by 200 into yield change in percentage point square plus C by 200 into yield change in percentage point square. After writing this formula, minus 1 into 3.79 into 1. This is modified duration. Change due to modified duration, and this will cover the gap between the true value and the value given by modified duration. So 23.4376 divided by 200 into 1 square minus 3.79 plus 0.12 minus 3.79 plus 0.12. So this plus 0.12 gives the adjustment of that gap. So that comes to minus 3.67%. Therefore revised bond value is equal to 100 minus 3.67%. Without calculator, 96.33 rupees. You will find that this value is closer to the value that we had got under PV method. Oh, I have to move a lot. 96.33 and this is 96.31, whereas the modified duration was 96.21. So once again it proves the answer based on convexity is closer to the true answer. Now write down one last part of this question. Revised price of the bond when YTM decreases from 10% to 9%. Revised bond price when YTM decreases from 10% to 9%. You don't need to write the formula again. In one question, formula will be written only once. So directly you come to this point. Minus 1 into 3.79. Only now the YTM is decreasing by 1%. So I have taken it as minus 1. Because I wanted to show you a problem with decrease in YTM also. Plus 23.4376 divided by 200 into minus 1 square. So this time it will be 3.79 and plus 0.12. 3.79 plus 0.12. 3.91%. 3.91%. Therefore revised bond price will be 100 plus 103.91. You see on the screen, only for understanding, this is what is the current price, this is what as per modified duration, but actual price will be a little more than what is given by modified duration, and this is true value. So therefore this time we have to add this number, and this answer is little higher than what is given by